Hi everyone, it's Joe again, and this is going to be video number 9 out of a series of 10 on impulse and momentum. And I'll start off by saying that the answer to the last video was 14.0 or 14, something like that. As long as you're in that neighborhood, I know talking sig figs is a problem for some people, and if you're getting in that neighborhood, that's good enough for now. I'm just trying to get the physics across to you, okay? Another thing I want to say is that I made the cover of the Rolling Stone. You may not believe it, but there I am. I'm the little guy on the far side there. And those other two guys, my friend Joe and my friend Lee, they used to be my students, believe it or not. And so you better be careful you don't get too close to me, otherwise you might end up being my personal friend or something like that. So anyway, yeah, this was a Christmas present, by the way. It's not real. You probably knew that anyway. So I'm going to go old school here, and I'm going to give you a question. The last couple videos are going to be on the conservation of momentum during explosions. And of course, this is going to be very elementary, I guess you might call it. But here is our first question. The first question goes like this. Let's see. A mass of 40 kilograms is initially at rest. This mass now explodes into two pieces so that one mass of 10 kilograms moves to the right at 10 meters per second. What is the final velocity of the second mass? Alrighty. So we know the physics already. The conservation of momentum tells us that the initial momentum is equal to the final momentum. All right, so let's take a look at the whiteboard here and see what we have going on. Here's my title, Explosions in One Dimension. We have a situation of a mass. It's not labeled 1 or 2 because it's just the mass. It's at rest. What does that mean? It means the total initial momentum must be 0. I don't have to calculate that. I just know it because it's not moving. That's what we're told. And then we go down to the final situation where we have the mass. It's broken into two pieces. There's the little piece we call M1. It's 10 kilograms. And we're told that its velocity is 10 meters per second. And I'm gonna label that with a positive number. Whoops, a positive number, and that's going to indicate for us that right is the positive direction. So we have not been given M2, but the numbers are simple enough. If M1 is 10 and the original mass was 40, then M2 must be equal to 30. I'll put, 30 is good, 30 kilograms. And we want to know the velocity of the second mass. We want to know how fast is this thing moving. Okay, so we'll put a question mark right there like that, like I like to do. Let's first start off with what is the physics, and I will also talk about my friend Dave, who was my tutor through university. He now teaches physics in a small school in Winnipeg, and he told me that he's able to do about 2/3 of his physics questions just with not calculating things, but you know what the other one I'm talking about is? There's qualitative and then there's quantitative. He's very qualitative. So what do we know? That momentum total initial is equal to the momentum total final. That's the physics. If you write me out a statement that says, oh, the total momentum at the beginning is the same as the total momentum at the end, I gotta give you something. because it's all true. Okay, let's carry on with our numbers now. So we have 0. Let's see, we have M1V1F plus M2V2F. Let's throw in the numbers. We've got 10 times 10 plus 30 times V2F. And this is still 0. This is going to be 100 plus 30 V2F, still 0. I'll move this down a little bit. By the way, this is about take 7 of this video. Let's move this around. I'll get down here and we'll go negative 100 is equal to 30 V2F. Divide out the 30. And that looks like a fraction that we used to do lots when we were just learning math. And this is going to be negative 3.33. Negative 3.3. Let's check our work to make sure we're right, okay? So we had 10 times 10 is 100. That was 30. I moved the 100 over here. And 10 thirds is 3 1/3, which is 3.33. And there we have it. So 3.33, but it's negative. So this is good. But we could also say 3.33 meters per second left. Did that all come out? Beautiful. Okay. Again, pause the tape as necessary. Okay, example 1's been done already. Example 2 coming up. Here we go. Suppose the original mass was moving to the right at 2 meters per second. Whoops. Instead of being at rest. This mass explodes into 2 pieces so that the 10 kilogram mass moves to the right at 4 meters per second. Whoa. What is the final velocity of the second piece? Okay, so just pause your recording there. And while you're doing that, and you can write that down, while you're doing that, I will change some of the things up here. Okay, go like that. That stays true. This will go all, we'll change this. This is question 1. All right. Now it's question 2. My goodness. All righty. So what's happening? In example 2, we have this mass is moving at, it's still 40 kilograms, but now its velocity is equal to 2 meters per second. And I'm going to put the plus sign in there. Let's see. Velocity is 2 meters per second. So that must mean that there must be an initial momentum. So the initial momentum must be mv, which is equal to 40 times 2, which is equal to 80 kilogram meters per second. Good. So what was the velocity of the first little piece when it exploded? I think we said it was 4 meters per second. M2 stays the same size, and V2F, well, we're going to solve for that again. So let's go down and I'll adjust this a tiny bit. So the total initial momentum is 80 kilogram meters per second. So the total momentum of the total momentum finally is equal to, well, we have M1 V final, M1 V1 final plus M2 V2 final. We have 10 times 4 plus 30 times V2F. And I'm just going to call this 80 over here. So 80 is equal to 40 plus 30 V2F. We'll throw that over there. We'll say 40 is equal to 30. Divide out the 30s. And we get 1.33 meters per second. 1.33 meters per second. And that's good enough, but let's put this in as well. So there we have it, 1.33. In other words, the whole thing is moving to the right, and at the end, once they've split up, they're still both moving to the right, and the total momentum stays the same. So I'm going to call it a video as done, and we got one more to go, and hang in there. It's been a good day so far. I hope you're doing okay too. Thanks.